This call is now being recorded.
Yes, good morning students. Am I audible in both classes? Kindly respond. Yes, okay, fine, thank you. What about in classroom 2? Yes, okay, fine. Wait a minute. Okay, so in the previous session, we have discussed about the multiplex 7 segment display and the dot matrix 8 cross 8 dot matrix display. Okay, the concept of programming both the device is going to be same. Fine, you have to enable one digit. Okay, before that you have to keep the data in the segment lines in the case of multiplex 7 segment display. Yes, coming to the dot matrix, we have a thing like that. Here we are enabling the column. Before that we are placing the pattern. Okay, what data we have to write, that pattern we are keeping. Yes, then we are enabling the first column. Yes, is the thing is clear to everyone? Is the things are clear? Yes, kindly respond. Yes, okay, fine. So now my question is, if you are going for the IC Max 7219, okay, you can able to interface 8 cross 8 dot matrix LED or 8-digit multiplex 7 segment display using 2 pins of your microcontroller. Yes, have you people checked? Any of you people searched in the internet Max 7219? What about that IC? At least anyone? Have you people checked or not? At least reply for that. Yes, Max 7219. That is the IC number I have told in the previous session. Okay, I will check in classroom 2. Classroom 1, nobody responded. No, at least Sajis is responding no, sir. Fine. Yes, Shivakumar, have you referred Max 7219? What about that IC? Locus Nega, Dixon, many of you told. Yes. Yes, what about the purpose of that IC? It is used to connect either 8 cross 8 dot matrix LED or 8-digit multiplex 7 segment display. Fine. So that which protocol it uses? That's my question. Okay. So far we are dealing with port operation. Yes, single bit of port we have able to control. That means we can able to write 0 logic or 1 logic. Similarly, we can able to write a logic available in the port pin. Yes. Then we have gone with byte of data. Yes, 8-bit data we can able to write or write. Fine. Even with byte operation, we can able to modify the interested bits. Yes or no? Yes. See, regarding the port, we have done so many programs. So many programs we have written. Yes. When we are interfacing any input-output device, most of the time we have to use the ports. Fine. Okay. Fine. Do you people? Yes, synchronous protocol. Yes, it is using serial synchronous protocol. Okay. See, it uses that protocol so that you will be transferring a bit by bit information. So it will be getting into that particular IC and it is converted internally as a 8-bit data. Fine. The serial data it's receiving and it is converting it as a parallel data. Fine. So based on the data we are writing, it is going to generate the scanning process and everything. We no need to do the digit enabling and disabling process or keypad scanning process. Fine. but that is mainly meant for display device only. You cannot able to interface any kind of keyboard to that. Fine. It is mainly meant for interfacing. Either 8x8 dot matrix LED, or you can interface plus 7-segment display 8 digits. Fine. Okay. So with 2 pins, you can able to interface many number of LEDs. That means 64 LEDs you are controlling with just 2 pins. Just imagine. Okay. Similarly, you have many other protocols. Fine. In this particular value-added course, we are going to see about the serial port alone. Fine. That means UART protocol we are going to discuss. Fine. Apart from that, you will be having many protocols, serial protocol. Fine. Regarding your automobiles, can you people guess which kind of protocol it is used regarding the automobiles? Yes, luxury cars and all. I hope some of you people are attending the workshops or webinars. Fine. Possibly you may hear the word. Yes, have you heard about the word CAN? Yes. Typing in chat CAN. It is the universal protocol used in the automobiles controller area network. Okay, there you will be having many number of controllers which are controlling the individual aspects of your automobile. Okay, see, your automobile is having many control unit, fine, many microcontrollers that are all integrated together, connected together using a CAN protocol. Fine. That means a microcontroller is getting some information from a sensor. Okay, and it is sharing to all the device. Whichever device it wants, it will consider the message, otherwise it will discard it. Fine. But only one message can be broadcasted at a time in the CAN protocol. Fine. See, many other protocol we are having, I2C, SPI, many things we are having, one wire protocol. Fine. Okay. So here in this value-added course, we are focusing about the UART protocol. Fine. Suppose if the value-added courses is continued for extended for few more sessions. Okay. Probably I will teach you such protocols. Okay. How it can be used for your application, or how it can be used for your project. Fine. Don't think we are just simulating and checking the result. Fine. Now you will be very familiar with programming and connection. Okay. What you have to do is you have to work with the real hardware. That is the only thing we are lagging. Yes. Okay. Fine. So now the very first thing what we are going to do today is this one. Okay. How to write an embedded C program to display the 2-digit numbers from 00 to 99, one after another, in a 2-digit multiplex 7-segment display. Yes, whose data pins are P1 and digit selection pins are P0. Yes, how many of you people tried, at least tried this particular program? See, I want to tell you one thing. Fine. To work in such kind of devices, say for example multiplex 7-segment or a dot matrix or LCD, whatever it may be, fine. You people learn and write a program, it takes more time. Fine. This value-added course, we are giving you an extract. Fine. I will do one thing. Probably at the end of today's session, I will share you one data sheet. Okay, one data sheet I will share you. You people go through it. Fine. I will ask more questions to you people. Fine. We will understand how much difficult without knowing a particular IO device operation to write a program. Okay, it's not an easy thing to write a program directly without the knowledge of the particular IO device. Fine. I am speaking about the LCD only. Fine. I will provide you the data sheet at the end of today's session. I will provide a link. If I forget, someone remember me at least. Okay, I will share you. Also, I will put it in the Google Classroom. Okay, you people go through it, fine, and you people study about its operation. I will have some few questions. I will have some questions in the next session. That means by coming Monday. Fine. Okay. Shall we write the program for this? Yes. Shall we write the program for this? Yes. Okay. Fine. So now what I'm going to do is I'm going to share my entire screen. Wait a minute. Actually, this Google Meet is changed. Enhanced, I think. Fine. Now I am going to present my entire screen. Yes, is the entire screen is visible to everyone? Yes, my entire screen is visible. Yes, okay. Now I am going to open the software. Wait a minute. Okay, fine. So what about the problem statement we have given? We have to display the number from 00 to 99. Okay, in a 2-digit multiplex segment display, whose data line must be connected to 1 and the digit control must be done with P0. Fine. P0 we can take only 2 lines, P0.1 and P0.0. 2 lines we can take. Fine. So first I am going to give the hardware connection, then I am going to write the program. Yes, is the screen is visible properly to all of you? Kindly respond in chat. Yes. Okay, fine. So now what I am going to do is I am going to connect the virtual hardware first. So multiplexed LED display I am taking. Okay, we are going to use only the lower 2-digit. So the upper 2-digit we are not going to make use of it. So 0 correspond to the last digit. So 0.0 I'm going to do with 0.0. And here I am going to do with 0.1. Fine. Coming to this, how we have connected? Port 1 have connected. Kindly keep ready with the 7-segment code for the numbers from 0 to 9 for this particular concept. So we are going to use common cathode. 0.7, 0.0, 0.0. Always you will connect A from the A to the LSB. From there we can start. 1.1, 1.2, first I will enable this option. Yes. 1.3, 1.4, 0.5, 1.6, finally 1.7. Okay, fine, that's it. So what about the first line we have to write always? We have to include the header file of our microcontroller. Yes. So hash include AT89S52. Okay. So we have to assign a macro for the port naming. Yes. So hash include data. I am going to consider it as a data. Fine. That means whatever I am going to write it in port 1, it is going to be considered as data. Port 1, I am naming it as data. Sorry, hash define. So hash define, I am putting include. Hash define data. Hash define control. Okay. Digit only I am mentioning it as control. Fine. Okay, now what we have to do? Now what are the things we have to do? I am going to start my main program. Void main. So here I have to declare the array. Yes. Port concat 7 seg of the value what you are going to tell, I will put it here. Fine. Kindly you people help me. Okay, fine. So here what I am going to do is I am going to write the main program. So initially what we have to do, am I audible in both classes? Is my screen is visible? Yes, okay, fine. Okay, now you people tell me what we have to do initially. Again, I will tell you one more time. So here I have selected common cathode. Common cathode means what? If you provide logic 1 to the digit control pins, it will connect to ground, or else it won't get connected. That means logic 1 to select the digit. Similarly, to turn on the LED, we have to write one logic. That means both digit control and line control, I mean segment control, are active high. That point I want to clear you. Okay, fine. Now you people tell me what we have to do now. Yes. What we have to do now? Just help me. Initially, what you want to display in the screen? The very first step, what we have to do? Why nobody is answering? Sir, my internet connection is not there properly. Yes, we have to. Yes, we have to turn off it. We have to turn off it. So for turning off the multiplex 7-segment display, first what I have to do? Yes, very good. 0x00. So what I am going to do is data. Yes, data is equal to 0x00. If you do this alone, you won't get any character displayed on the screen. But I am also going to disable the digit control. I mean digits also I am going to disable. Yes, DNTL control is equal to DNTL and with 0x. I am going to use only lower 2 pin now. So what about the data I have to use? Yes, the lower 2 bits I have to clear. Yes, what I have to do now? F0. Only I am going to using the lower 2 pin. I am not going to use the other pins. Is it F0? F0 will work. But what we have to do now? Only lower 2 pins I want to make it 0. Other pins must be 1. Yes, what about the data? Yes, very good. FC. Thank you. Fine. So with this 2 line, what I have did, I have cleared the 7-segment display. Fine. Here I didn't connect it. Please listen. Here I didn't connect the upper 2 digit. Lower 2 digit only I am going to use. Fine. That's why I am programming only the lower 2 pins. Fine. Now what I have to do? You should have some variable. Yes, you should have some variable for maintaining your number. So I am declaring as num. Yes. Now what I have to do? It has to be put in a loop. Continuously it has to happen. After entering into this particular line, while of 1, it is going to repeat the thing again and again. Yes, at the very first line, what I have to check? I told it has to start from 00 to 99. After 99, what it has to do? After 99, what it has to do? Yes. After it reaches the maximum value, 2-digit maximum value 99, yes, it has to repeat. So what initially I have to check is if number is less than 100. Yes or no? If the number is less than 100, we have to display it. For displaying it, what we have to do? See, it is a 2-digit number. We want to display in 2 position. First, what we have to do? You write it as 00. You 00. No. First step, what we have to do? If I want to display 78, what I have to do initially? The data to the lower digit is equal to 8. The data to the next digit is equal to 7. Yes. So it is having one data, it is having other data. From a single data, I am obtaining 2 data which are to be displayed in the individual thing. Yes, we have to split the digit. How it can be done? For example, if I give an input as 68, it has to provide 6 and 8. Okay, for storing that 6 and 8, what I am going to do is, I am going to use a variable D1, D0. Yes, D1 stands for the number to be displayed on digit 1. D0 means the number to be displayed on digit 0. Yes, how we can split the data? Yes, very good, very good. Okay, but here we are dealing with decimal number. Yes, here we are dealing with decimal number. So num modulo 10. Okay, modulo 10 we can use, or else num modulo 0a you can use. 0x, 0a you can use. Please remember one thing. When I say hexadecimal, a is equal to 10. Correct? Okay. Now what I am going to do is, initially I have to provide a value for the number. The very first time, it has to be declared with the value 0. Yes. If I didn't put 0x, it is simply a number 0. That's it. Decimal number only. Fine. Now what I have to do? D1 is equal to number divided by 10. Similarly, D0 is equal to number modulo 10. So I get the digit splitter. Correct? Yes, that's it. So if the number is less than 9, it will enter into the loop. If it is greater than, less than 100, less than 100 means it will enter into this loop. If it is greater than 99 means what? That means if it is just equal to 100 means what? The number has to be made 0 again. Fine. So initially what I am doing, I am taking the number. After I have taken the number, I am incrementing it. Yes. Number equal to number plus 1. That's it. Right. Now I am going to display it. Yes. How we can able to display? For displaying just 2 digits, no need to go for looping concept. Okay, it might go in a tedious way. Fine. So here I am simply going to enable or disable that pin. Yes. So for this, what we can do? You have to keep the data for the digit position 1. Yes, what you have to do now? Data is equal to what we have to do? First you have to keep the data, then you have to control the digit. Yes, first I am going to keep the data. What about the data? Whatever the number I got in D1. For example, if I want to display 78, 78 divided by 10 is will give you the quotient as 7, correct? So that 7 has to be displayed on the multiplex 7 segment display. For this, what I have to do? 7 seg of D1. Data I have kept. Next, what I have to do? Control. TNPL is equal to 0x 0x. Wait a minute, I am writing now. CNPL and with 0x FC 0x FC, then odd with 0x 02. Is it clear or not? எப்படி வந்து புரிஞ்சுதா இல்லையா? I'm using only 2 pins, or else you can go for bit operation. That will be fine. Yes or no? You can also go for bit operation. What you have to do at this particular step? P0.1 is equal to 1. That's it. You can do like that also. After I have done this, again what I have to do? I have to clear it. CNTL equal to same line. This line I have to. That's all. So with this three line, I have displayed the number, the upper nibble. That means the upper digit of a 2-digit number. I'm displaying, I mean tens position of the number, I'm displaying in the digit position. Fine. So I have to repeat the same for lower digit. Yes. So in the 3 line, I have displayed the upper digit. Fine. Initially, I am calculating the number. So here, what I have to do? D0 I have. So that is the data. Yes. Here, what I have to change? 0, 1 I have to put. It is going to remain constant. That means if the number is less than a value, first what will happen? D1 and D0 are calculated. Then the number is incremented by 1. Fine. Then we are displaying both the numbers. That's it. So that's all about the if statement for the number less than 100. Next, what we have to do? Else what we have to do? Else what we have to do? If the number is greater than 100, the previous time, if it is 99 means 99 plus 1 will be 100. Yes. Coming to this else statement, when it will enter, the number is greater than 99. What we have to do? Again, it has to do from the beginning. What we have to do here? Yes, what we have to do here? Kindly respond. See, if the number exceeds 99, what you people told? We have to again start from 0. So what about the number we have to make? Am I audible? Yes, very good, Logo Sneaker. 0. Yes. Num is equal to 0. That's it. If you put 0x means you are dealing with hexadecimal number. If you simply put a number means we are dealing with decimal number. Both can be supported here. Fine. Don't worry about it. Is the program is clear? Is the program is clear? Any doubts? Any doubt? Okay, இந்த program run பண்ணி பார்க்கலாம் எப்படி வருதுன்னு பார்ப்போம். Before that, I want to initialize the 7 segment code. What is the 7 segment code? Zero means A, B, C, D, E, F, G. All, sorry, G, A, B, C, D, E, F. That means what about the data? I think 3F. Correct? Can you help me out? Am I right or wrong? Not 3, 6. I think it's 6. 3F. Okay. 06. Thank you. Next. 5B. 0x 5B. Thank you. Next. 4F. Next. 66. Next. 0x60. Yes. 0x. I think lovely put all B2. I will copy it directly. Thank you. Yes, this is about the segment 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes. 0, 7, 6, 7. So now the program is okay. So what I have to do first? I'm going to save it. I'm going to compile the program now. This program won't provide you a correct output. I will tell you the reason. You just guess what about the reason. I'm going to run it. I have to turn on the hardware. Not properly working, right? Okay. The things are not properly getting incremented. Why? It's working. It's overlapping one character over the another. Why? Yes, let me start from zero. Yes, delay. Please listen one thing. Please consider one thing. You have to run it. You have to run the program to display the character at least for some time. Correct? At least for some time. So what we have to do? We have to display the number 0 for some time. Then we have to display the number 1 for some time. But please remember one thing. If you put delay program, it will get into the delay program. At that point of time, this scanning won't happen. This scanning should happen at the same time. Delay also occur. Delay should also occur. Yes, what we can do? Yes, what we can do? Any idea? Yes, wait. I will do one thing. In the main program, I am going to create one variable. Okay, I'm going to create one variable at P. Okay, so it is mentioned as P. Okay, suggest P times we are going to run display single digit. Yes, display digit here in this portion. This 6 lines. This 6 lines. When I display the number 0, yes, this 6 lines has to be repeated at least for certain time, so that you can stably see 0. Then what you can do? The next digit, you can display that thing for a moment. See, like that, we have to write the code. So for this, what I am going to do is, I am going to use the for loop here. For t equal to 0. Yes. And minimal value give me. P plus plus. Real time you have to give some more value. Otherwise, you may not be able to see the character properly. Yes. Wait a minute. This for loop will execute at least for 5 times, so that you can see a stable character 0 appears first. Okay, for the first time, then it will keep on continuing. Yes. Okay, so now I'm turning on the display. Now I'm going to run the code. To wait for a while. Yes, 0. Now 1. Is it overlapping now? Students, is there any overlapping now? Clearly you can see the display. Yes, clearly you can see the display. Yes. Is it clear? See why I have put count file is for simulation purpose, but in real time you can give some more time. It should not be much time. It should be around in the order of milliseconds. Okay. See, simply I am incorporating a function inside delay loop. Usually, what we will do, delay means a dummy loop we will put. Here, what I am doing in dummy loop, a function I am doing within a for this much of times. Fine. Wait a minute. I will keep the counter slow, minimal. Okay. Wait a minute. I will keep it 3. See the result. 3 or 2. Give it 2. 2 times. Still factor. Because we have to see the result. Wait a moment. Yeah, 0, 1, 2, 3, 4. We may not be able to wait for more time now. Wait a minute. For that, what I am going to do is I am disabling and enabling the hardware. That's it. So now it is about 88, 89, 90, 91, 92, 93, 94, 5, 96, 97, 98, 99. Then it's going. Fine. Is it clear to everyone? Is it clear to everyone? When it is changing from 99, a moment you can see 09, then it is changing 99. Am I right or not? Am I right or not? Yes? Am I right or not? Yes, நல்லா clear-ஆ observe பண்ணீங்கன்னா தெரியும். 91, 92, 93, 94, 95, 96, 97, 98, 99, 0900. Yes, it is changing like that. To overcome this in real-time application, what you have to do is, after it reaches 99, you should not only be the number as 0. You should also do one more thing. What you have to do? What you have to do? Yes, any idea what you have to do here? Yes. Turn off. Very good. You have to turn off the control, then we can display the number. Okay. So what I'm going to do is CLPL is equal to CLPL and of 0x. So that you should not see garbage results. Otherwise, it will display 09. See, if I disable this hardware, means the program will run faster. Yes, 72, 92, 93, 94, 95, 96, 97, 98, 99. Okay, still better when compared to the one, it's still better. Fine. Okay. See, that's it about the concept. Now you people can do a digital clock. So this you consider as a minute. Okay, this you consider as a hour. That means what? After it reaches the count 59, this particular digit has to be incremented. This number has to be incremented by 1. Fine. Once it changes up to 23. Yes. After that, it should change 0000. Like that, you can do. Fine. So this is going to be one task I am going to give from module 2. Fine. Module 1, I have given only simple task. I hope you people are having 1 day holiday tomorrow. Fine. So I am expecting you people to present the task what I assigned for you people. Okay. All individual people I have assigned the task. Okay. Randomly I will ask anyone to present. So all of you be ready with your presentation. Yes. At least you have to open the screen and you have to explain the program. You have to just show the output. That's it. Okay. Fine. So now we will go with the next one. So this program is over. Fine. Now I am going with the PPT. Yes, this program is over now. What about the next thing we are going to do is, so this already we know. Column and configuration. I will give you every thing about formation of the number pattern. Fine. How to display the number pattern. That concept I will explain you. Fine. So here I am asking you to write a numeracy program. Display the number from 0 to 9, one after the other. 8 dot matrix display. Yes. Rows must be connected to P0. Column must be connected to P1. Fine. I will tell you for one digit. Consider it is for 0. Yes. So like this you have to generate. All LEDs must be turned off first in the first column. Then this pattern has to be followed. For this you have to create data that I have told you in the previous session itself. Yes. Can you people see if it runs faster, how it is going to happen? Yes. Okay. If it still runs faster, it appears like this. If the concept is clear, yes, if the concept is clear, keep the data for column 1, enable column 1, yes. Keep the data for column 2, enable the data, keep the data and enable the column. Yes, next data, enable that column. Like that you have to keep on continuing. Is it clear to everyone? Is it clear to everyone? How to form the data? From the MSB you go. For example, here I am using common cathode. I mean column cathode, not common cathode, column cathode. Column you have to connect to ground. That means last 0. All other column must be 1. So 0, 1, 1, 1, 1, 1, 1, 1. That means 7F. 7F is the initial data. Correct? Okay. Then what about the data I have to write in the rows? So that in column we can have all LEDs turned off. Yes. What about the data I have to write? If I write one logic to the rows, I can see the LED in the particular question will go. Correct? Yes. For the first column, what about the data? You people only proceed to the program. First column, column C0. Yes. What about the data I have to write? I mean, to the in the row, what I have to write when I'm scanning the, yes, very good. Logos nega, very good. 0, 0. What about the second one? What about the second one? When I'm scanning column C1, what I have to write? Yes, very good. 7C, very good. Fantastic. Next. What about the next thing? What about the next column? When scanning the next column, what data I have to write in the row? Yes, very good. 8A. Next. Next. 9-2. Next. All are hexadecimal value. Please remember. Okay, 9-2. Very good. Next. A2. Very good. Next. 7C. Again 7C. Then 0, 0. Thank you. Thank you. Fine. Now we can able to form the pattern for displaying the number 0. Fine. நம்ம கண்டுபிடிக்கிறது இந்த மாதிரி தான் பேட்டர்ன் ஃபார்ம் பண்ணணும் அப்படின்றதுக்கு you have a standard format. Yes, yes, you have a standard format for all your computers. Okay, based upon the font you are installing, the number 0 can be appearing in the screen in different. Fine. If it is capital letter, it should be like this. If it is small letter, it should be like this. If it is Times Roman font, it should be like that. If it is Calibri format, it should be like this. See, everything you are installing your computer. Font, if you are installing in computer, okay, can you people say whether we can able to see the Tamil wording, the Word document? Is it possible? Is it possible or not? Can you type Tamil wording in Microsoft Word? Yes. By default, it can be done, or we have to do something. Yes. By default, whether it will type in Tamil, you can type in Tamil, or you have to do some extra thing. Yes, we need to do. What we have to do? We have to install some software. Correct. So that software, what it will do? Yes. That software, what it will do? Will install the fonts. Okay, I will show you. In the control panel, you can see. Somewhere you can see fonts. You can see some folder. I don't remember. Okay, there will be one particular folder. So there all the letters, A, B, C, D, regarding the English letters. Okay, regarding the Tamil wording, you have all the alphabets. Yes, in that particular font file. Okay, fine. So similarly, we have to form the data for displaying a particular number or letter. Fine. Here you can display anything. What are the things possible with this 8x8? You can do it. Fine. It's not a problem. But how it can be done in this way? You have to fix ones and zeros in the position of the LED to be turned on and turned off. You have to put 1 in the position of the LED to turn on, 0 in the position of LED to turn off. If it is column cathode. Yes. If it is column anode, we have to put zeros. Inverted value we have to put. Yes. See, for this, in yesterday class, I have told you. Yes. In yesterday class, I have told you. Wait a minute. I will do for 1 or 2 numbering. A minute. Yes. In the previous class, we have discussed this only. Okay. You can fill the pattern as you like. Okay, first we will display some character, random character in the display. For example, I am going to create a square box inside a box like that. First we will do like that, then we will do our program. I am creating a outer box. Yes, now what I am going to do is I am going to put a cross mark. Whichever font you can develop. Okay. See, in the font also you will be having different types, 5 cross 8 font, 5 cross 10 font, many things are there. You check whether it is appearing like this or not. That's it. So this is the font I want to display. Yes, can you people tell the data, array of data for this? Yes. Yes, what we have to do? Quickly tell me what about the data we have to write. So first column, what about the data we have to write? All ones. That means what? Yes, FF, then FF, then C3, very good, then FF, C3, A5, very good, 99. Next, 99, in reverse way we have to go, A5, C3 and FF. Shall we do this first? Shall we do this first? See, kindly remember one thing when I am teaching, when I am going to teach you LCD, that you can also form your own characters. Fine. By default, it is going to have the font for all the letters and numbers. But apart from that, you people can create own characters. Fine. So now I will go with the program with this. So here what I have to do about the problem statement I have told. We have to use P0 for connecting the row, P1 for column. Wait a minute. Wait a minute. I will minimize all the things. I will just open the app. Yes. Now. So first thing, I'm going to give the hardware. So already I have used the 7-segment display. I'm going to close it. So now what I'm going to do is dot matrix, LED matrix you have to take. Yes. Row where I have to connect P0. 0, 0, 0, 0, 0, 0, 0. So what about this question? 7, right? 7, 6, 5, 4, 3, 2, 1, 0. So I have connected the rows to port 0. Fine. Now I have to connect the columns. I'm connecting the column to port 1 now. Please wait a minute. See, if you able to display a pattern in the dot matrix, then you can create your own characters. Okay, then you can display it, no problem. 7, 6, 5, 4, 3, 2, 1 and 0. Okay, one more thing I want to tell you, I forgot to tell. If you want to save this configuration, you can save it and later you can use save configuration. I think it's out of the screen. Okay, so I'm saving it as .mat. Okay, suppose if I want to load that virtual tool, go to virtual hardware, load. I think the screen is upper. I cannot able to see it. Sorry, peoples. See, if you do like that, you can able to find that hardware. You can use it for any number of times whenever it is needed for your application. Yes, no need to give the connection again and again. Fine. So here I am going to keep pad out interval to somehow 50. Okay, mapping I have to do random. Color we can go for green. Okay, fine, that's it. Okay, fine. Now we can write the program for this. Yes, here we can modify the code. Fresh, I am going to write hash include ap89s52.h. Then I have to mention the row. So hash define row I have to use for port 0. Hash define column I have to connect to port 1. Yes, I have to create the character array. First we have to type port on scar. Now you can give the naming. Yes, here I am going to use dot matrix. Dot mat equal to. Can you people tell that once again? Can anyone type whole thing? Okay, I will refer it, no problem. So 0x ff 0x T3 0x A5 0x 99. So this I have to repeat in the reverse way, right? 0x 99. So again 0x 99 0x A5, yes, 0x C3, finally 0x F. That's it. Okay, so now what I am going to do is I am going to write the main program. So in the main program, first you have to turn off all the LEDs. So for this, what I am going to write? I am going to write the data like this. Column is equal to 0x 00. Mere doing this particular operation will disable all the digits. Yes. Okay. Now what I have to do? Okay. Sorry. Here it is column cathode. I have to put FF. Sorry. Column must be turned off. Fine. If you do this alone, all the LEDs will get turned off. So now what I am going to do is while of 1. Within this, I am going to write a for loop. Okay, I can have some pattern. So for loop, I have to initialize a count value. So char n or C I can put. It will shoot column. Yes. for C equal to 0, C less than 8, C plus plus. Can you people understand why 8? Why 8 here? Why exactly I am putting the number 8 here? How many columns we are having? Yes, 8 columns. Very good. Very good. Okay. So first what I have to do, I have to keep the data, right? So to keep the data, what I have to do? Row is equal to, simply row is equal to, what we can do? Dot mat of, what I have to put in between? Any idea? What value I have to put in between? What I have to mention in between? Dot mat of C. Very good. First time it is going to be 0. So first pattern will come into the row. Yes. Now what about the column we have to do? Column what we can do? See here I have to shift the negative logic. There are two methods we are having for this. One I have told in the previous class itself. Yes. Any idea? If I put 7F as a data for pattern, when I am shifting to the next time, it won't provide me BF. Okay, it will provide me 3F. So what I have to do? I am going to have the positive logic. Now, if you write 80 except the column 1, all other column what will happen? Enable, correct? So this I am going to write shift 3 times, but I have to complement and write, that's it. I have to complement and write, that's it. So after I have did this, what I have to do? Yes, I have to disable all the lines. That's all. Okay. If you run this program, you can able to see that particular pattern. Wait a minute, we will check it. File, save, simulator, debug this file. Yes. Now I am going to run the program. Running very slow. Okay, fine. Here it is running very slow. So what I am going to do is, I am going to increase the padding interval, pad out interval. Yes, can you people see? But it is in the reverse order. Why it is in the reverse order means I have to select mapping when light up. Row equal to 1, column equal to 0, right? Yes, now we will check. Wait a minute. Now it will get updated. Wait a minute. See, as it is simulation, as we are doing it in simulation, doing in a very slow manner. But if you run in a real hardware, at the instant for executing the program, you can see. Yes, is it visible? Yes, is it visible? If I turn on the red color, you can see. See, this is the thing we want to display now. Yes. Yes, is the pattern created or not? Yes, fine, fine. So now what we need to do is we have to display from number from 0 to 9. So what I have to do? What I have to do, peoples, students? we have to create the 7 segment, dot matrix pattern for pixel pattern for all the numbers 0 to 9. Yes. Okay, I will do one thing. I had shared one Excel file in the Google Classroom today. So in that you can see here. So I have already created this particular thing for all the 10 digits. Yes, 0 to 9 I already create பண்ணிருக்கேன். Wait a minute, I am going to fill it here. Yes, I am going to fill it here. Yes, that's it. Yes, that's it. So this is for displaying 0. Yes, previously we have did display 1, 2, fine. So I have did in a array like this, fine. So totally 64 things are there. Totally how many? Sorry, 80, not 64, 80. 80 data we are having in the array, fine. If you didn't put double underscore code, it will occupy the RAM memory, 80 bytes from the RAM memory, fine. Out of the 256 byte in 8089S52, 80 bytes it will be used for this purpose alone, fine. Okay. So now what I have to do? Now I should have one variable. The main program I am going to declare it like the previous one, num is equal to 0. That's it. Num is equal to 0. That's it. Okay, while 1 program it is going to execute for infinite times. Okay, so what I have written inside this particular loop, it is for displaying a single character. It is for displaying a single number. Okay, so what I have to pass in this particular thing? I have to first turn off the dot matrix. I have did it here. Okay, then after entering into this particular program, what we have to do? What we have to do? Okay, wait a minute. I will tell you what you have to do. Okay, so for c equal to 0, c less than 8, c plus plus, that's fine. That's going to be fine. I want to display the number 0. Correct? So in this array, where the first character pattern for 0 is located. Kindly help me out. In the array, what about the position of the first character? First character that I have to display in the dot matrix available. Position, I am asking about the position. Yes, this is the first character. In which position it is available in the array? Kindly help me out. Whenever you say array, it starts from 0. Am I right? 0, 1, 2, 3. Yes, 0. Very good. Okay. Okay. What about the second pattern? Second column. I mean column 1 data. Position 1, 2, 3 up to 8. Okay. What about the first character for displaying the number 5? In the position la irukum. Solla mudiyuma? How it can be found out? Any idea? Fifth position la iruka? Just think and tell me. See, if I say the number 1 means it is available in the 8th position. It starts from the 8th position. Yes. So 8, 9, 10, 11, 12, 13, 14, 15. Again, digit 2 starts from 16th position. Digit 3 starts from 23rd position. 4 starts from 32. 5 starts from 40. Yes. So how we can relate the position of the starting pattern? The number multiplied by what factor will give the first data? See, if I want to denote a position of the, yes, very good, 8. We have to multiply it by 8. That's it. That's what I am asking you. Yes, that's what I am asking you. So what I am going to do is, in this particular for loop, dot mat of not C. What you have to do? You have to give the numbers. Okay, numbers. You have to initialize. I have initialized here. Wait a minute. I have initialized here. So here I am going to use a for num equal to 0. Num equal to 0. Next, num less than 10. Num plus plus. Wait a minute. Yes, num plus plus. A minute, I will make the indents proper. Yes. Okay. So I have to close this bracket. Wait a minute. Yes. So num equal to 0 means, what about the value I have to fetch? Num multiplied by 8 first. Num multiplied by 8 first. Okay. To that I have to add C. Is it clear to everyone? Is it clear to everyone? Is it clear or not? Row data, how I am fetching? From the array, the number multiplied by 8 plus C. If I want to have the first data for number 5, what it means? 40, then 41, 42, up to 47. Yes? From 48, the first pattern for 6, the letters, the number 6 will start, correct? So you consider, or else you can create 2 cross 2 array. That's fine. Then you can create a 2 cross 2 array. Sorry, not 2 cross 2. 10 cross 8. Yes, you can create an array size of matrix array size of 10 cross 8. Yes, 10. Yes, why it is 10? So 10 numbers we are having 0 to 9. For each number we have 8 things. Yes, yes, very good. Fine. You can create a 2-dimensional array. That's what I said, 2 cross 2 like that. Fine. Sorry for that. So 2-dimensional array you have to go for. The size of the array must be 10 cross 8. So 10 rows and 8 columns. Or else you can directly go with this. Both are going to be same only. Fine, that's it. Okay, now we will run the program and check the result. You won't get a proper result. At the beginning itself, I am telling you people just think why it is displaying like that. Wait for some time. Yes, first it displays 0. Yes, whether it is displaying 1 or overlapping on the previous thing. Are you seeing the display in a proper manner? Actually, it is working, but it is writing one after the other. Yes, overlapping. So what we have to do, as I told in the 7th segment, the same concept you have to implement here. What you have to do? You have to execute this particular program, this inner loop for displaying a single number, say for 3 times or 4 times, so that it will work properly. For this, what I am going to declare is I am going to use one more variable. A minute. P. Okay, so I am going to put that for loop here. For P equal to 0, P less than 3, P plus plus. Wait a minute. I am having some cursor problem. Wait a minute. Yes, that's it. See, that single character I am going to repeatedly display for 3 times. Then I am going to increment the number and doing so and so. Fine. You will see. We have to wait for some time because the simulator initially it won't provide any output for 800 microseconds, right? So after that only it is starting to provide the outputs. We'll wait. Yes, now 0 written. Yes, 0 is appearing for some time. Okay, now also overlapping at best. So we have to do one more thing. What? Yes, what we have to do? Students, what we have to do? We have to clear and write. We have to clear and write the next pattern. Yes, I think somebody unmuted. Yes. Kun sir. Wait a minute, I will mute everyone.
ஆன்சர் சொல்லுங்க.
இல்ல யாரோ அன்மியூட் பண்ணிட்டு இது பண்றாங்க. சந்திரன், சந்திரமௌலி. It is visible. It is not properly changing again. It's again overlapping. Yes, what we can go for? Any idea? Any idea what we can do? Okay, if I might reduce the fad interval, see in real hardware definitely it will work out, students. Wait a minute. Padding very fast, so I have to increase the padding level. Wait a minute. That is my cursor. Cursor is not moving. Wait a minute. Yes, it is not also working. Wait a minute. See this pad interval, pad out interval, we have to properly so that it might work. No, still I have to increase. Yes, I think it's okay now. Fine. See, if you do it in real hardware, definitely it will work. I will do one more thing. இதில் நம்ம அந்த கேரக்டர்ஸ் பார்க்கறதே கஷ்டமா இருக்கு இல்லையா, டிம்மா தெரியுது. வெயிட் a minute. Here what we can do is we can complement and write the data so that at least we can see the character properly. We'll wait for some time. Yes, now you people can see. Wait a minute. I'll change the coloring to on green. Wait a minute. No, it's not working. Wait a minute. I think it's trying to display 2. Yes, now it is displaying 2. I think there is some problem with this simulator. Okay. See, if it is running at a faster rate, we can find out the proper character. Okay. This is the drawback we are having here. Wait a minute. I will show you at what speed this current program is running now. Not able to expand it. Yes, here you can see. In the order of millisecond, it is executing. Yes. So now it is 4. Yes, that's it. See, it is working only. The thing is, the fad out interval we have to adjust properly. The code is working properly. No doubt in that. So that fad out interval we have to change it appropriately. Regarding this hardware, if I keep lesser value, yes, it is getting fade away. Wait a minute, I will keep it long value. Six. Okay, fine. Yes, you have to keep some large value so that it will work. See, this simulator, unfortunately, we do have to do the setting, but in real hardware, it will work properly. Yes, that's it about the dot matrix LED. Okay, so next we will get into the serial port. Fine. So before programming the serial port, we have to understand. We have to understand what are the different modes or operations are there, and how to program the serial port of 8089S5. Okay, fine. Now I am going to minimize this. I'm going to stop my presentation and I'm going to present only the PowerPoint. Fine. Yes, is the presentation is visible in both classes? I think so. Yes, is it visible? Yes, okay, thank you. So now I will go with the presentation. So now we are going to discuss about the serial UART. Okay, so you people know very well what about the nature of the serial UART we are having in 8051. The same we are having in 8089S52 also. Okay, yes, whether it is simplex or half duplex or full duplex. Yes, yes, it is full duplex UART. Very good, very good. It is full duplex UART. Very good. Fine. So now what we are going to discuss is the features of 8051 serial UART, which is the same available in 8089S52. Okay, so it can be operated in 4 modes. Okay, at variable baud rate. Fine. So kindly note down the pin numbers P3.0, P3.1. Okay. So P3.0 will act as a receive pin, reception pin, and 3.1 will act as a transmission pin. Fine. Like this. So RxD is a input to microcontroller and TXD is the output from microcontroller. Fine. So we are having only one pins for transferring the serial data. Okay. So one pin for receive, one pin for transmitting. Fine. So what happened inside this serial UART? Yes, this thing will happen. Please carefully listen. We are having 2 SBUF register. One is write only, the other one is read only. But we are having only the same name, SBUF, simply SBUF. That means what? If you write something on SBUF, it is going to be a transmission operation. Okay. If you read something from SBUF, it is from the receiving data. Yes, the received data you are going to read from SBUF. Fine. So here it is a 8-bit data we are writing into the SBUF, but we are having only one pin out. So which type of shift register we have to use it here? Yes. Which type of shift register we have to use here? Kindly respond. You are providing a parallel input and it is producing a serial output. Yes, which type of shift register we have to prefer for transmission? Of course, you have to convert the parallel data to serial data so that you can transmit one bit after the another. Yes. So which type of shift register? You have studied 4 types of shift register, am I right? Serial in, serial out, serial in, parallel in, serial out, parallel in, parallel out. Regarding port and all, parallel in, parallel out. Yes, parallel in, serial out. Thank you, Logus Nega. Fine. Coming to the reception position, reception part, which type of shift register we have to use? On seeing the image, you can tell. It is having a single input pin, but it is having an 8-bit bus output from the shift register. Yes. What about reception side? Kindly respond. Yes, serial in, parallel. Yes, for transmission of a data, we need parallel to serial converter. For reception of the data, we need serial to parallel converter. Fine. While transmitting, we are having only one register, but in the reception, please kindly see one shift register. After receiving the 8-bit of data, it is transferring to SBUF and it is ready to read the next bit. Next byte. Yes. Why it is like that? Why it is like that? Any idea? If you are receiving a byte of data, before reading that byte of data, if it comes with the next byte of data serial input, what will happen? Will disturb the previous one what I have received. Yes. So after receiving 8-bit data, it will be automatically moved to SBUF. From there we can able to read. Fine. If you didn't read before the next byte fully occupied in the shift register, it will get overwritten by the next value. Yes. See, it is mandatory to read the SBUF register whenever there is some data. Fine. But transmission side, no worries. We are going to write. Okay, transmission is under our control, but reception, I cannot tell. This part of time, this controller will send this data. I cannot able to say. Fine. So we have to give priority to reception rather than transmission. Yes. Transmission I can do at any part of time, but reception at the moment when we are receiving the data, it has to skip whatever the work it is doing and it has to gather the data. Yes. Fine. So it has 2 buffer register with same name, SBUF. So one is for reception, the another one is for transmission. So reception happens through RxD pin, transmission happens through TXD pin. TXD and RxD are serial data transmission and reception pin. Yes. So writing a data into SBUF will initiate the transmission based on the mode of operation. Yes, after transmitting a byte of data, automatically an interrupt we will get, that we call it as what? Transmit interrupt. Yes, similarly, okay, transmit interrupt indicates that a byte written on SBUF is transmitted successfully. Yes. Coming to the reception, okay, if the reception of serial data is enabled, it's very, very important. Transmission, no need to enable. At the moment when you are putting the data, the transmission automatically starts. But reception, you have to enable or disable as per the requirement. Yes. After a byte of data received into the SBUF, read-only SBUF, an interrupt will generate, that we call it as receive interrupt. Yes. So this and all you know already very well. Now, what are the serial UART SFRs we are having? That means what are the SFRs we are having to program the serial UART? Any idea? We will be having only one SFR to program the serial UART. That means for control the mode of operations. Yes. For putting the data or reading the data from the serial port, we need one more register. Yes, 2 registers. Okay, SBUF, SCON and SBUF. In PCON, only one bit to control the baud rate. Okay, SMOD, like that, one bit will be there in the PCON register, so that we can use it for double the baud rate. So that's why it is called as double baud rate bit. Fine. First, we'll go with the SCON word format. So this is the word format. You people know very well. SM0 and SM1 will decide the mode of operation. SM2, it's for multiprocessor communication mode. Then REN, if you set this particular bit, reception will be enabled. Then coming to the mode 2 and 3, we will be going for 9-bit UART. So for transmission and reception, we need one more bit to store the data along the normal one. Fine. So that you will be having 9-bit of data. Then TA, RA are the interrupt flag bit. Whenever transmission is finished, TA flag will get set. Similarly, whenever reception is over, RA bit will get set. Fine. Okay. Fine. SM0, SM1 are mode selection bit. Kindly take a screenshot of this. If I make SM1 and SM1 00 mode 0, 01 means mode 1, 10 means mode 2, 11 means mode 3. Fine. So shift register mode, 8-bit UART mode, 9-bit fixed baud rate, 9-bit UART with fixed baud rate, 9-bit UART with variable baud rate. That's it. Fine. The difference between the modes are sometimes either by the baud rate or by the size of the data. Fine. Next, REN, already I have told you. SM2 bit, it is used for multiprocessor communication bit. We are not going to discuss much about this. Yes, REN, it must be set by software to enable the reception of serial data. Yes, it has to be reset by the software to disable the reception of serial data. Next, SCON register, next bit, TBA and RB8. It is mainly meant for 9-bit UART. Yes, is it clear? Then last TA and RI bit. If it is set, transmission is over. RI bit, if it's set, a byte of data is received. That's it. Okay, I don't want to spend much time on this. Okay, how to configure the serial UART? For example, find the value to be loaded in SCON. To configure the serial UART, operate in mode 1, the reception enable, disable multiprocessor communication. Kindly find the word format, word value. I have to load in SCON. Mode 1, reception enable, disable multiprocessor communication mode. Fine. So all other bits must be reset. Yes, what about the value we will be getting? Kindly fill it out. Mode 1. What about SM0 and SM1? Zero one, very good. 01, very good. I want to disable the multiprocessor communication mode. Yes, very good, Shivkumar. 01, 01. The remaining 4 bits initially we can make it as 0. Fine. We are dealing with 8-bit UART. Mode 1 means 8-bit UART. T and RI initially we must reset. That's it. By default it is in reset condition only. Fine. So we have to fill 01, 01, 00, 00. So what about the 8-bit data? Yes, 50 Hz. Thank you. 50 Hz. Okay. So coming to SBUF register, so it's a 8-bit register. Basically, there are 2 registers will be there. So one for reception, one for transmission. That's it. This no need. Mode 0 means shift register mode. No need. Mode 1 we are going to focus. Yes, 8-bit UART mode. Okay. When I say UART, it must follow a protocol. Yes. UART protocol, Universal Asynchronous Receiver Transmitter Protocol. According to that protocol, Okay, according to that protocol, this must happen. Initially, the line must be in marking position, then zero logic must avail for one clock pulse, then the data followed by 8-bit data followed by optional parity bit. I didn't mention the optional parity bit here. Fine. So optionally you can have a parity bit 1 bit, then finally we have stop bit. Then it will again go into the marking position. That's it. Yes? Is it clear? 90H, sorry, 50H is the value we have found to configure the SCON register. Fine. Here we are speaking about the word format. That means this we call it as frame format. Fine. So start bit, 8-bit of data. Optionally you can have a parity bit, then stop bit. That's it. Fine. Okay. Start bit logic is 0 and stop bit logic is 1. That's what we have mentioned in the diagram. Fine. So directly I am going to move into this particular portion. Baud rate calculation. Yes, baud rate in mode 1. Kindly take a screenshot of this. Kindly take a screenshot of this. Okay. Can you people tell me when I say variable baud rate, which timer I have to use? We are having two timers, timer 0 and timer 1 in 8051. Which timer I have to go for? Yes. Which timer we have to use? Timer 1. Very good. Very good. Timer 1. Yes. So that you have to configure the timer 1 as a timer. Timer bar counter 1 as a timer. Okay. It should create some counting purpose. It should create some overflow rate. Fine. So the timer 1 overflow rate is going to be the input for the serial port. Please carefully listen. The internal pulse is divided by 12. It is available to the timer. Correct? So this timer will generate a pulse based upon the count value I am going to put. That means what? Timer 1 overflow rate. For example, 12 machine cycle is equal to, 12 clock pulse is equal to 1 machine cycle. So for every 1 machine cycle, you will be getting 1 pulse to the timer. Whenever the timer overflow, it will generate 1 pulse. So that value divided by 16 or 32 based upon the SMOD bit value. Fine. So we are going to consider SMOD is equal to 0. So we have to divide it by 32. So finally to the serial UART. What about the clock we are getting? FOC divided by 12 divided by 32. Is it clear to all of you? What about the frequency I am giving as a input to serial UART? FOC divided by 12. That is again divided by 32. That is given to clock. Yes? Yes or no? Timer 1, okay. See, kindly respond. You are not a, yes, okay. See, appada formula puriyum. So how we have to calculate the count value, that you can understand only if you understand this concept. FOAC first divided by 12. Then it has to be divided by 32 if SMOD equal to 0. Yes, that is the clock input we are giving to serial UART. So if you want a particular baud rate, that clock divided by the baud rate value will give the count value, so that I can load it in timer 1. That's it. Fine. Carefully listen. Baud rate is equal to FOAC divided by 12. That is the very first thing I have told you. FOAC divided by 12. Very first thing. Then if SMOD equal to 0 means 1 by 32. Again we have to divide by 32. Yes. That value divided by 1 by 256 minus TH1. Where TH1 is the count value I have to put, and 256 minus TH1 means what? Overflow rate. That's it. So timer 1 overflow rate depends upon the value you are loading in TH1. That's it. Is the formula is clear to everyone? Today we will do at least one program. கொஞ்சம் குயிக்கா ரெஸ்பாண்ட் பண்ணீங்கன்னா ஒரு ப்ரோக்ராம் இன்னைக்கு பார்க்கலாம், நம்ம சீரியல் ப்ரோக்ராம். எஸ், இந்த ஃபார்முலா புரிஞ்சுதா இல்லையாப்பா? FOSC divided by 12, then that value divided by 32, again that value divided by the timer overflow rate. Fine. So baud rate is equal to, what about the formula? What about the formula for baud rate? So baud rate is equal to 2 power S mod divided by 32 into FOC divided by 12 into timer 1 overflow rate. Fine. So timer 1 overflow rate, how you can find out? 256 minus TH1. For example, if I put 255, okay, 253, yes, 254, 255, 256. For every 3 count, it will get overflow. So overflow rate I have to mention here. Yes. So now I have to convert this particular formula so that I can know TH1. So I am rearranging all the things. So this is going to be our formula. Yes, FOSC divided by 12, that value divided by 32 as S mod equal to 0, that value divided by baud rate, it has to be subtracted from 256. See, 256, how it comes? 255 plus 1. That's it. Fine. So kindly note down this formula. Straight away we can start writing the program. Okay. So find the count value to be loaded in TH1 of timer 1, configured in mode 2 for generating the baud rate of serial UART at 9600. Yes. So count value enna load pananum. 9600 baud rate I need. Clock frequency is 11.05 into megahertz. S mod equal to 0. Kindly substitute all those things. 256 minus 2 to the power 0 by 32 cross 11.05 into mega divided by 12 cross 1 by 9600, which is equal to FD. Kindly note down the value. When I say serial UART, I also have to program timer 1 in the case of variable baud rate. Fine. Okay. Directly now I am going to write the program because we are having very lesser time. So sum of the standard baud rate and count value we got is 253 for 19200 with S mod bit equal to 1, 4800 with S mod bit equal to 0, the value must be 243. Like this, we have different baud rates. So variable baud rate means timer 1, it depends. So timer 1 overflow rate, we have to fix it. That will decide the baud rate. Okay. So this and all we can skip it off. Yes. What are the things we have to do to program the serial port? Configure the serial UART using SCON register. Then program timer 1 to generate the baud rate. Then write a byte or wait for some time to read a byte. That's it. Is the things are clear? Is the things are clear to everyone? Yes. Yes, fine. I will take some 10 minutes to finish the program. Wait for a minute. Wait for a minute. So this is the program we need to write. Yes. What I am going to do is I am going to configure the serial port at the baud rate of 9600 in mode 1. Okay. And transmit the message welcome to KCE. So this has to be repeated at regular interval. For this I am going to write the program. Okay. Okay, quick. I am going to open the window now. Presentation. Shall we proceed or we will continue in the next class? I am giving you the choice so that I can calculate the values at least. Yes? Okay, we can proceed. Okay. So you people have to help me out for finding those values so that I feel very easy. See, if you know serial port programming, you can program many devices. You can interface Bluetooth device. You can go for GSM module. You can use fingerprint module, RFID reader. Most of the higher end devices, when compared to LED and 7-segment LED, you can able to interface microcontroller if you understand port programming. Fine. Okay, now what I am going to do is I'm going to write the program now. Wait a minute. Wait a minute. I will join from my another laptop. Okay, we'll write the program. We can see the result in the next class. Okay, because in this we don't have the virtual hardware for serial port. We don't have the virtual hardware to display the serial data. Fine. Unfortunately, it doesn't have. So what I'm going to do is I'm going to stop it. Yes, I'm going to write the program now. Yes, I'm going to delete this entire program. Okay, you people let me help. So first line, what we have to do? Program we will write, output we will see in the next class. Okay, program we will write, output we will see in the next class. Wait for some time. The cursor is not working properly. Wait. Cursor hangs. Wait for some time. I will made it correct. Yes, okay. Yes, what about the first line we have to do? Quick. Program output next class paakalam. Past include the header file 8089s52.h. That's it. Fine. Next, what we have to do is we have to define FOSC. What about the frequency? 11059200, which is equal to 11.058 mega. Fine. So initially what I have to do? What about the clock to the timer? That is FOSC divided by 12. Yes. What about the clock to the serial UART? Yes. S clock. I am putting it as S clock, which is equal to T clock divided by 32. I am considering S mod must be 0 in your program. Fine. So I am going to write the main program. So in the main program, what about the first line I have to use? What about the first line I have to use? Kindly tell me. I have to program the, yes, we have to make the baud rate as 9600. Very good, I'm done. For this, what are the steps I have to follow? I have to configure first SCON register. What value you people told me? Mode 1, variable baud rate. The reception enable. What value you people told me? Do you people remember? Go with the PPT. Yes, very good. 0101. So the lower 4 bit, what we have to do? Okay, fine. Directly I will type it. Hexadecimal, it is going to be 0x. That's it. So next, what I have to do? I have to program the timer. So first, I am going to stop the timer. PR1. I am stopping. Then I have to configure it in mode 2. Yes. Why mode 2? Any idea? Why I am preferring mode 2? Any idea? Kindly respond. Why I am choosing mode 2, timer operation? Fixed baud rate, no Shivakumar. Any other answer? Yes, any other answer? No, 8-bit UART only. Sorry, mode 1. Sorry, mode 1. I am very sorry. Mode 1. We are preferring mode 1. For that only we have write the word format. Yes. Regret for that. Mode 1. Yes. I'm speaking about the timer. I'm speaking about the timer mode 2 only. I asked timer 1 mode 2. Serial UART I'm configuring mode 1. Timer I'm configuring mode 2. Why? What about the description for mode 2 operation timer? Yes. Why mode 2 for timer 1? Yes, 8-bit. Additionally, one thing I am expecting. Mode 1 it is 16-bit timer. Mode 0 it is 13-bit timer. Mode 2 it is 8-bit timer. That's fine. What about the additional thing you have to say? Kindly search and tell me. 8-bit count, okay, Anthony Surya. That's fine. It is having one feature. It is not available in the other modes. No, Lepasnega. I am asking about the meaning for mode 2. See, you are confusing with the mode of operation of serial UART. I am asking about the timer. Timer 1 I have to program. Correct? So the timer I am preferring to program in mode 2. Why? That's my question. Appa, very good. Anthony Surya, thank you so much. Auto reload. Yes. Classroom 2 I will see. Anybody responded? Sajis responded timer 1. Okay. Thank you. So auto reload. For auto reload purpose, we are going for mode 2. That's it. So 0x 20. Directly you can write, or else what you have to do? PMOD and with 0x 0f, that should be R with 20. With this program, I will stop today's session. Please wait a minute. Baud rate configure பண்ண வரைக்கும் பார்க்கலாம். Then we will stop. Fine. So now what I have to do? Mode of operation is fine. Now what I have to do? I have to introduce a variable char b. So that b, what I have to do? P is equal to SCLK, okay, divided by 9600. This is the baud rate you people need to do. Correct? Or else here itself you can do. Yes. So B is the value which will give me the value to load. Yes. So 256 minus. You people can understand now. So what is S clock? T clock divided by 32. What is T clock? FOC by 12. So FOC by 12, that value divided by 32, that value divided by baud rate, which has to be subtracted from 256. So I can have the value in B. That's it. So now PH1 is equal to B. PL0 is equal to B. Now I have to turn on timer 1. That's it. So these are the lines I have to use for configuring the baud rate. Yes. If you need, you can calculate here itself. Okay. How we can calculate? As defined. Baud is equal to 256 minus SCLK divided by 9600. That's it. நீங்க டிஃபைன் பண்ணிட்டீங்கன்னா டைரக்டா நீங்க என்ன பண்ணிக்கலாம்? வேல்யூ எடுத்து அங்கேயே யூஸ் பண்ணிக்கலாம். ஃபைன். So with this, I will stop today's session. We'll go with the program. We will continue the program in the next session. Okay. So as of now, I have configured the serial UR baud rate. That's it. Okay. In the next class, we will discuss how to write the data, stream of data into the serial UR. Fine. So now I am going to stop the recording. If you people have any doubt, you can stay and ask. Otherwise, I am going to stop the recording.